Hi there, Lorenzo here from OmniSir. Today I'll explain how to implement your custom vehicle step by step, in order to fully utilize every feature of the framework. Firstly, let's talk about preparing the assets we'll need. I'm using Autodesk Maya, but the process will be the same for Blender. Once we have modeled our custom vehicle, we just need to export the skeletal mesh of the Riviera from our Renovate project and then import it here along our vehicle. We can delete the Riviera mesh and keep just its rig, adjusting the position of individual joints according to our needs. I've already done all of this, including the binding process between the mesh and joints, as well as painting the skin weights. Basically, all the weight goes on the root joint, except for what needs to move. Under the joint called Animated, you can find all the doors, hood, trunk and dashboard joints, plus the antenna or front lights if needed. All these weights are a simple matter of 1 or 0, all in or nothing between the respective bone and the root. The same goes for the wheels. Then we have the axles, which are a bit tricky cause they need a linear gradient weighting from the attachment point to the end, whatever shape it may have. The suspensions then are divided among the various damper joints, which represent the upper end of the suspensions, and the axle damper joints under the front and back axles, representing the lower end. All these joints should have a linear gradient to properly extend or compress the suspension. Just in case we have disc brakes and calipers to manage, under the front and back axle joints there are additional joints called wheels mechanics designed to follow the steering but not the wheel rotation, to which the caliper and any other necessary part should be assigned. For UVs, my method involves using 5 UDIMs divided by category: bodywork, chassis, internal surfaces, internal objects, and glass. Glass should have thickness, so that the material would properly work once we are in Unreal. I pack everything as compactly as possible and then assign a different material to each of these layouts, finally overlapping all the UDIMs at the origin of the grid before proceeding to texturing. Let's move to Substance Painter for a moment so I can explain how to set up your textures for the correct use of value mask and the color palette system present in the framework, allowing us to change colors freely directly in Unreal. Once I've textured my vehicle, I use an additional channel, in my case the specular level, to create a mask where I represent with grayscale fillings the various areas to which I will then change color. Opening a color palette can help us understand how to proceed. The elements of its array correspond to the decimals of the value that these areas have on the mask. 1 or white is for all parts that don't need to change color. Paint is at 0. The various parts of the internal carpet and door padding are these interiors 1, 2, and 3. So their values are 0.1, 0.2 and 0.3. Seats are on 0.4. Details, at 0.5 can be mattes, finishes, or wheel rims. This level is a bit free for you to use. At 0.6 and 0.7 we find wrap 1 and 2 used for racing liveries to assign sponsors and various graphics colors. Finally, at 0.8 and 0.9 respectively, we have the rear lights and the brake light so as to allow the system to turn on all the emissive areas correctly. Export your vehicle as a FBX file, including the rig. So now that we've created our assets, let's set them up in Unreal. We start with the vehicle's FBX file. Once dragged into our content browser, in this dialog window, we need to set the framework's base skeleton as the reference skeleton for this asset. Besides that, we just need to specify not to create default materials, and then we can import it. This way, we'll get the skeletal mesh of the vehicle and a physics asset link it to it, while our skeleton will always remain the default one. To ensure that our vehicle moves properly, we need to prepare a good physics asset. For now, we can open it and delete anything inside, as whatever was generated by default is unusable. Preparing the collisions of our asset requires us to trace the essential shapes of our vehicle with a series of basic convex shapes in our modeling software, as you can see here in my example. Each of these meshes will then be renamed UCX, mesh name 01, 02, 03, and so on. Once we export these along with the corresponding mesh and import them into Unreal, it will recognize them as custom simple collisions. Once we've done that, we can then copy them into our physics asset, and that's it. We'll then use a different approach for the colliders of all those parts that we want to open and freely simulate physics. We can prepare a second UCX file where we'll reposition all the colliders we need so that the pivot of their bone corresponds to the center of the grid. After importing this file into Unreal, we can then copy these UCXs to the door bones and all the other animated joints, deleting any unwanted meshes each time and repositioning the remaining ones correctly using rotation and scale snapping. Now that we have all the collisions in place, we can right-click on the root bone and create a constraint with all the other animated bones. This graph helps us select the various constraints and bodies to call up the correct settings. For each one, we should set the angular limits which, as long as you've used the Riviera rig, will all be locked except the first one. Then set the angles you prefer, and finally, we just need to orient the constraint correctly. To do this, simply rotating it is not enough. You see this arrow rotating? It shouldn't. To correctly rotate the constraint, we need to hold down Alt. So let's position everything correctly and test it. If we want, we can add springs to keep the doors open. Activate the angular motor with twist and swing and set the desired force and angle. Let's try it out. You see, the doors open and wave, pulled by the force we have set. They're trying to reach position 0, which in this case is the center of the angular limit of the constraint, that is, a half-open door. Fairly accurate, but we need to reduce the waving. We can start by setting up the body correctly. Let's select both from the graph. First, defining their mass in kilograms makes a big difference. Then we can set an angular damping equal to 4, simulating the friction between the components. Under Advanced, let's set a max angular velocity of 400, to prevent those situations where Unreal treats things like paper sheets. Finally, each constraint must have parent dominates on true, or it will prevent the car from moving. And each body must also have simulation generates hit event on true, so that impacts are properly recorded. We can now duplicate an existing vehicle template. Once opened, simply change the skeletal mesh with your own. We then have to move all the components to the right position. I do only a bunch of them for now, so we can immediately move to the rest. In my case, there's a small problem with the seat height, so I immediately set my driver seat socket 12 cm lower, while I raise the driver interaction socket by the same 12 cm. In the blueprint self-settings, I set a seat height offset of -12 to correct the height difference with an automatic lerp. Let's try it out a little bit. At the moment, my vehicle is moving strangely. It doesn't steer well, for starters. I search for a mass in the self settings. I close the physics category that we're not interested in. Under the two Renovate categories, I find two parameters that control the center of mass, which is currently too high and therefore I reset it, and the center of mass offset, which comes into play when the handbrake is used to favor slides. Let me show you the difference between a center of mass at 0, at 10, and at 20. Depending on the needs, we can set this as desired. To customize the vehicle's performance better, we need to set up the vehicle movement component. In the meantime, we can duplicate all the external elements that we can. Under Blueprint, Vehicle Logic Wheels, there are the two default wheels used by our vehicle. We can duplicate and rename them in a subfolder called Settings in our vehicle main folder, along with the default steering and engine torque curves we can find in Data, Curves, Vehicle Curves. We can then replace these files in the movement component. The torque curve is limited by this value, max torque, which, when raised, allows us to have greater thrust, as long as we model the curve accordingly. We can select the points we are interested in, and enable the transformation cage. At the same time, we turn off the two-grid snapping. By moving the pivot here to the corner, below in the details we can set a new maximum height. More height means more thrust, while horizontally we have the engine RPM. So if I wanted more acceleration in reaching torque, I could raise the initial part of the curve. Or I could extend the tail to have more thrust while pulling the gear. We can also use the cage itself if we're more comfortable that way. The steering curve, on the other hand, controls the decay of the vehicle's steering potential at high speeds. It represents the steering potential vertically from 0 to 1, and horizontally the speed in kilometers per hour. So we can adjust it in its length and how deep it gets. In the wheels, we find many useful settings. For now, I can widen the tires to a more suitable 15 centimeters of thickness. Having done this, I would like a bit more grip and maneuverability than in the previous tests. I increase the values of cornering stiffness for both wheels proportionally, and I do the same with the values of friction force multiplier. After a second test, the car is definitely more responsive and faster. I can adjust the transmission a bit if necessary by modifying the rates of each gear in transmission setup. The last important setting is transmission efficiency, with which we define how much energy is lost between the actual torque of the engine and how much thrust the wheels receive. More or less, that's all there is to know. If I forgot something, feel free to let me know in the comments. See you soon with some new videos.